Good evening, ladies and gentlemen. My name is Glen Gilchrist, I'm Head of Science at Newport High School. I was trying to improve very quickly something that we've been working on for the past couple of years, which is using our students to actually do some genuine research in the classroom. And I'm going to start off, maybe it's arranged on this thing, yeah. I'm going to start off by saying that actually using research in the classroom is probably one of those things that we think we do anyway. And it's part of the standard kind of things that teachers do. We ask students to go away and research something. But I want to just throw out there that research is actually going to find out something new, something that no one's ever done before. Because if students are actually going to look at things in a book, they're not really researching, are they? They're kind of finding out information. But yet we in our heads dress it up. And all you're doing at BTEC lesson, for example, is go and research something. So what you actually need is go and look at the answer in the book and you'll find the answer there. And then just write it down, maybe transform it in some way, but you're not actually researching. So I just want to put out there that maybe it's self-evident what research is, but that we don't actually get that going in the classroom. So I just want to point out something for a start, which is from a very famous educator in America. His name's Dan Meyer, it's all to do with mathematics. But the word that I want to introduce at the moment is pseudo-context. And that is that when we set up our lessons, we come up with an idea and we think it makes sense as a teacher, but if you actually deconstruct what's going on, and here's a particular problem, I think it's in Swedish, and the text actually says, you catch a pike. The scales are broken, I think they mean the scales are actually that you're trying to weigh them on, not the scales of the pike. The scales are broken and you want to weigh it, yeah? But somehow the scales are broken, but you know it weighs 2 kilograms plus half its weight again. How do you know that if the scales are broken? So we're already breaking the context of what we've set up. But we've set up a problem that makes no sense. Anybody in the room know the answer to the question? It's a student question that we'd expect our kids to know. The answer is it weighs 4. A little bit of algebra, we can work our way through it. But the context that we've set up is false in the first place because it doesn't make sense what's going on. And I want to go through, just very quickly, in fact, we have this idea of totally implausible or untrue contextual situations that we set up for our students that we expect them to engage with. Okay? Typical ones are you're in the canteen, you hear two students over here, two students talking about some practical activity or some experiment they did in classroom before lunch. Really? I've never heard students talking about what they did in lesson when they went to the canteen. Even more popular is imagine you're describing a cat to an alien. I've never come across an alien, and I don't think any of our students are ever going to bump into an alien. But we've all done it. In all of our lessons, we've given them a context that is just so flatly untrue and never going to happen. But it makes sense when we're writing the lesson plans and when we're constructing it. Or the completely irrelevant context, which is a whole bunch of blurb that we expect our students to read that supposedly sets the context, typical exam question, and then we get to the point where actually the questions have nothing to do with the context because it's a comprehension and they just have to skim and scan and find the answers. But it all makes sense when we set it up. So I'm going to try and bring that back to research in the classroom. I, as a science teacher, loathe this experiment with a passion. And anybody who's been through the secondary education system in this country or anywhere in the UK would have done marble chips and acid. Why? I have never come across marble chips and acid in my real life outside the classroom ever. And I don't imagine any student ever will. It's a lovely experiment for proving the point. Yeah, as a teaching thing, it's great in terms of getting across concepts and ideas as a teaching thing. But we have this idea where we'll dress it up as research, we'll say do a practical activity, and what I want you to do is go and research what happens when you alter the surface area of the marble chips to see what happens. Like we don't know what's going to happen when that happens. Also, though, students can go and look up the answer on Google in the first place. So if students can Google your Walt, I want to throw out there the fact your Walt is wrong in the first place. Because if students can just find out the answer to your lesson by looking it up, the way that we've constructed it, the context of the lesson, needs to be thought about. So very rapidly, what we've been spending the last couple of years doing in Newport High is trying to come up with a context that students can buy into. So marble chips and acids done with snail shells, which had never been done before, we presented it to the British Mollusk Society, because no one had ever looked into acid rain and snail shells and the effect of the strength of the snail shells. We looked at measuring the surface albedo of various substances and surfaces, because normally done by satellite, very expensive. So our sixth formers came up with an idea using digital cameras and pieces of paper and measuring the relative amount. We submitted that, thank you, we submitted that to the Global Albedo Project. The final thing is we looked at the link between PE and making you smarter. I have a class for year 9s before PE and after PE, a double lesson. It's like a PE sandwich with PE as the meat and filling. And I have them before PE and they're all kind of really excited and happy. They don't learn anything, they're all really happy and excited because they've got PE. They come back from PE, you think they've all run about 50 miles and they're all kind of dead. But surprisingly, they learn more after PE than before PE. So we did some work on the physiological effects of PE in terms of things like heart rate, pulse rate, and reaction speed. And we proved conclusively that the students at this end of the scale, whose heart rate went up the most, so I guess the unfittest students, their reaction times decreased the most. So if you believe there's a link between reaction speed and intelligence, our students did some work, submitted it to Cardiff University in support of the fact that they believe that there is genuinely a link between PE and making you cleverer. The point I'm trying to make, and what I want to bring it back to, is if we avoid pseudo-context within a lesson, and we actually frame our lessons in the real world, students will engage in something because they can do some real research. Not the canned research that we expect them to do because we already know the answer and we're not going to tell it to you, we're going to find it out because it's like some big secret. Actually, something that I don't know the answer to. Realistic problems. No fishes and scales, you know, we've got to stop doing that. And the final thing is, if we learn something new, we can publish our results. And other speakers have already mentioned the power of taking those results and getting them published in peer-reviewed journals. It is much more than me giving them a sticker or the head giving them a merit or something. The fact that other people in the world have engaged in what they've done and fed back to them has actually been much more rewarding than actually anything I can do. So my plea is, actually, our students are doing some real research, because deep down, they know more than we do sometimes about asking questions. Thank you.